In this video, we'll discuss the resolution algorithm. This is the process by which Prolog determines if a user's query is either true or false. So the input to this algorithm is a query from the user, which is known as the goal. And the output is going to be true, plus whatever unifiers are necessary, if the goal can be satisfied. Otherwise, it'll return false. So in brief, a goal can be satisfied or resolved if it unifies with a fact in our database, or if it unifies with the head of a rule, and the conditions of the body of the rule can each be resolved in turn. And that's essentially what this algorithm says. So we start with a goal, let's call it G, initially set to whatever the query was. So just whatever the user types in, that's our original goal. And we've seen a bunch of different queries. We can have just single clause queries or multiple clause queries. Whatever that is, that's the original goal. We want to satisfy all of the sub-queries or the sub-goals in the original query. Right. So starting with a query and some sort of knowledge base, we want to state whether or not that query is true, and if so, for what values. So we'll start with the first sub-goal from G. Let's call it G sub 1. Okay, and we attempt to unify that with something in the knowledge base. So Prolog will search the knowledge base from the top down, attempting to unify G1 with each clause as it goes. Okay. We've seen the rules for unifying before, so we won't go back to that. But if there's no match, then we're going to do some backtracking. We'll come back to this idea of backtracking in a little bit. For now, let's deal with the else case here. So otherwise, unification succeeds with either a fact or a rule. We're going to end up with a new goal. So if our goal was originally G, which was just the query, we're going to get G prime, which is this new version of our goal, which changes under the following conditions. So if we unified with a fact, then it's real easy because the facts they're not conditional on any other piece of information. So if our goal unified with something in the knowledge base, then we already know it's true. We can just simply remove that sub-goal from our overall goal. Okay, that just means our job got a little bit easier. We solved part of our solution, so our new solution is slightly smaller. On the other case, if we matched with the head of a rule, then what we're going to do is take the body of that rule and substitute it for the subclause that we're trying to satisfy. So if we're trying to satisfy G1, and G1 matches the head of a rule, then our new goal, G prime here, is everything that was in G originally, minus G1, but then plus the body of whatever rule we unified with. So in that case, our goal likely got bigger. Okay. All the while, we'll keep track of any unifiers so that when we're done, we can actually return them. Now, goal, again, is initially the query, but as Prolog attempts to satisfy this query, the clauses of the goal are going to expand and shrink as we find rules or facts, respectively. Now, if we reach a state where the goal is null, say if G prime is empty, so let's say our entire query was just one clause that unified with a fact, so we simply removed that clause from our goal. Now our goal is empty. Great. We've proved all the sub-goals, so success. Okay. Now, if that's not the case, then there's still some goals left to resolve, so we just repeat. So we call resolve on this new goal, G prime, which is likely slightly bigger or possibly slightly smaller if we had a fact and many initial goals to satisfy. So we call resolve. We end up back at the top with our goal now being G prime, this new version of our goal. Okay. So let's see these simple cases, and as I mentioned, we'll come back and figure out what happens in the failure cases where we have to learn about backtracking as well. But let's see an example to explore this. So in our in the uploaded code, you should find people.pl. There's a knowledge base here representing some people and what it means to be friends. Let's see here. So some notes about what it means to be a friend. Friend is two friends are two people that share a same hobby. So according to this rule anyways, two people are considered friends if they share the same hobby, they're not the same person, and their age is relatively similar. So within 2 years of difference. Anything else I need to say about this? The ABS function here, this just means absolute value. So we're going to do a subtraction here. It doesn't matter which one's bigger or smaller. We just want the difference. And it's worth pointing out that the order of these terms is very important. We'll see later on why that is, but specifically here, let's say, these variables can't be unbound variables if we're going to be doing subtraction, right? We have to have unified those variables in previous lines with actual numbers so that we can do some actual arithmetic later on. So the order of these instructions is very important as well. So let's walk through the resolution algorithm for a few queries here. All right, so let's open this up in Prolog. There we go. So we have some facts about some people, some hobbies. So we have each fact here is a person's name and their age, and each hobby is a person's name, person who exists here, and one of the hobbies that they enjoy. Okay, and then people are friends according to the rule that we just saw. So let's query, are Alice and Dave friends? So friends, Alice, Dave. Okay, let's just run through and see what it says. It says true, but let's actually trace this and see why it's true. So trace friends, Alice, Dave. So that will unify. So this is our initial goal, right? G is set to Q initially, and our query is just this one expression. So this goes through our knowledge base top down looking for something to unify. Now it won't unify with any of these facts because they have different functors, but it will unify with the head of this rule. Same functor, arity2. We have unbound variables person1, person2 here. We have constants Alice and Dave there. So according to the unification rules that we've learned, that should unify. Now, what that means for our resolution algorithm though, because this is unified with the head of a rule, this goal, this sub-goal here, G1, it's the entire goal initially, gets replaced with the body of the rule that it unified with. So this expression, friends, Alice, Dave, now becomes hobby, person1 doesn't equal person2, and all these things down here, with person1 being Alice and person2 being Dave. Okay. And we can see this through the trace, so this unified with the head of our rule, and now we try to resolve through these expressions. Now notice we're going through these expressions in order. So the first one to be evaluated is hobby, Alice, something. So person 1 here is Alice, hobby we don't have a value for, so empty variable. And that now tries to unify with our knowledge base. So it walks through top to the bottom, won't unify with any of these people. Here's a hobby, so that will unify with hobby, arity2, that's great. And then individual term-to-term comparisons, Alice unifies with Alice. So then the next expression is, what about bird watching? Well, bird watching will unify with this empty variable, where that empty variable gets the value of bird watching. So now hobby, as our rule called it, now has the value bird watching. So success, we managed to unify that with a fact. And now that makes our goal, which was all of these expressions, right? Our goal was to satisfy all of these different terms. Now a little bit easier, right? We've satisfied this one, so the remaining goal is just everything else here. But we've managed, we satisfied that with the unifier that hobby is now bird watching. So the next expression says, is there, for this next one, hobby person 2 for some hobby, where person 2 is Dave from our original query, and the hobby variable is bird watching from the result of the previous step. And that's true. That unifies with one of the facts. So we go down through all these hobbies. These will all unify hobby arity2, but then Alice won't match Dave in our query, so that doesn't work. Bob won't match Dave, so it comes all the way down to the bottom here. Dave will match Dave, that's great. And bird watching matches bird watching, so those will unify. We have no unbound variables, so no new unifiers. But we can just creep through, and now that's successful as well. So now our goal gets one smaller. We have a new sub-goal here, or new G prime, you could say, starting with person 1 does not equal person 2, where again, both of those things have values. So Alice doesn't equal Dave. That's obviously true, so we can creep through. And now we have person 1, which was Alice again, comma age 1. So this is asking what is Alice's age, because we don't have a value for that second term. So that will go through our knowledge base and unify with person Alice 20, where age 1 equals 20. There you go, person Alice 20. And then it tries the next one. Our goal is getting smaller and smaller. Person 2, which is Dave, and again we don't have an age for Dave, so it unifies with this line where age 2 also equals 20. You can see that here. And then our goal is just now these last two lines. Age diff is the absolute value of age 2 minus age 1, where age 2 and age 1 both got values from the previous lines, both set to 20 as we can see in our trace. Right, so we have 20 minus 20 is 0. The absolute difference of 0 is, the absolute value, of 0 is 0. And the is says to do all those calculations and then unify. So age diff gets the value 0. So this empty variable is the absolute difference between 20 and 20. So we get 0 is that. And then we're on to this last line where now that age diff variable equals 0. So we have 0 is less than or equal to 2, which is true. So the whole thing succeeds. We managed to prove all of the sub-goals of the rule of this body, the body of this rule, which means we proved the head of this rule, which our initial query unified with, which means our initial query is true. So we kind of covered a lot of that before, just sort of at broad strokes, but now we've seen how the resolution algorithm will go step by step, left to right, top to bottom. So it's going to satisfy all of the expressions in the goal or the sub-goals left to right. So it goes hobby person 1 before it does hobby person 2, before it says person 1 does not equal person 2. And then it goes top to bottom through the knowledge base. So when I need to find a hobby, it will first unify with Alice birdwatching before unifying with Alice programming, for example. All right, so let's now talk about what happens in the failure case, this backtracking. Let's just stick with this example. So when resolving a goal fails, a number of steps or a number of possible conditions are true. Let's start with what happens if the top level goal fails. So if I ask a query like person Ellen age, how old is Ellen is what this is asking. So we're asking to unify this query with something in our knowledge base. So we walk through the different persons, and none of them have the atom Ellen as their first term. So in that case, this can't unify with something in our knowledge base. So if it's a top level query and that fails to resolve, then the whole thing just fails. Okay, we just get false. So there's not really much to the backtracking there. There's no other decisions that could have been made in that process. We can't find any possible way to prove that Ellen is a person of some age, so we can't answer that query. All right, so it's top level goal, resolution just outright fails. Second case is if it was the first of one of a sub-goal, so if we manage to unify with the head of a rule, which has a bunch of sub-goals, and if it was the first of those, then the parent goal, the rule head in that case, will fail. And let's see an example of that. So if we ask friends Ellen, comma, Dave. So again, Ellen doesn't exist in this knowledge base, but let's see what happens if we ask, is Ellen Dave's friend? So we trace into this. So that does unify, or attempts to so far, unify with the head of our rule in our knowledge base. So we get friends person 1, person 2. Where person 1 is Ellen and person 2 is Dave. So that succeeds, but now our goal becomes the body of that rule. So it gets replaced not just determining friends Ellen Dave, but determining hobby, person 1 doesn't equal person 2, etc., etc. Starting with the first one, hobby Ellen something, which means we need to figure out, is there a listing for one of Ellen's hobbies in our knowledge base? So this goes through all the different facts for hobby. It will unify again at first, so we have the same functor, same arity, but then it fails to unify when it gets to trying to unify the individual terms, because Ellen here, the atom that we're providing, doesn't match any of the atoms that already exist, and there's no variables. So that fails. Now, there was no other decisions we could have made up to this point. There's only one rule for friends. There wasn't any other ways to prove that two people are friends. So even though I managed to unify that first step to say that the initial query unifies with the head of the rule, we weren't able to prove that rule. And since it was the first sub-goal in that rule, then the whole thing just fails. Okay, so we couldn't prove that Ellen has a hobby, so that means we can't prove that Ellen and Dave are friends, and the whole thing gives up. Snooze. There we go. Next. So the third case is kind of the bigger case where the name backtracking comes from. If we're not the first sub-goal, and we're not one of the top-level goals, then what we're going to do is try a different value for one of the previous sub-goals. So that means if we're not the first sub-goal and we're not one of the top-level goals, then we've already gone through a few steps here. We've already resolved some of the sub-goals. So what we're going to do is unresolve some of them, ununify any unifiers that we've made, and try a different match. So look for something else. So let's see an example of that. Let's try friends, Charlie, Ellen. So again, Ellen doesn't exist, so this is going to cause some problems for us. But our initial query is, are Charlie and Ellen friends? That will unify with the head of our rule, so that's great. And we go into the body of the rule. So is there a hobby for Charlie? Well, we can go through and say, hobby, Charlie, LARPing. Charlie likes to LARP, so that's the first hobby for Charlie, so success there with hobby equals LARPing. Then we go on to the next step here and says, is there a hobby for Ellen that matches that? So hobby, Ellen, LARPing. Does Ellen like to LARP? Well, that goes through the facts, and there is no fact that says that to be true, so it must be false. So that fails, but we're not done yet. So we got to this stage, and we couldn't prove it this way. So we couldn't prove that Charlie and Ellen can unite over LARPing, but maybe they can unite over something else. So we get a redo, which is we go back, and we try and say, is there a different way we could have answered this query? Notice that's the same as this first step we took up here. So we said, hobby, Charlie, something. We said, yeah, sure, LARPing. Ellen doesn't like LARPing. What else does Charlie like? So we go back in, and the search resumes from where it left off. So it said, there's hobby, Charlie, LARPing. But if that doesn't work, let's backtrack, let's undo that unification, and see if there's something else Charlie likes. So continuing on, the next one says, well, Charlie also likes bird watching. So we can unify that statement with hobby, Charlie, bird watching. And does that bring us to a more favorable condition that we can resolve the initial goal? So we walk through, and so if hobby is bird watching, is there a similar fact that Ellen likes bird watching? Now Ellen doesn't exist, so that's going to fail as well. So it's going to backtrack. But now there's no other possible combinations for Charlie here, right? And Prolog knows this. It has some optimizations in the tracing. So it's not going to just say, well, could I have tried Dave? It knows that there's no other hobbies for Charlie, so there's no other ways to resolve this sub-goal. So then the whole thing has to fail. It backtracks. That was now the first sub-goal that failed, which means there's no way to prove Charlie and Ellen are friends. Okay, so if the first sub-goal in a rule fails, then the whole rule fails, and we're done. Let's see one other example here, a little bit more of an involved example with this backtracking. So friends, how about who are Alice's friends? So Alice, friends Alice, and then someone Y. Let's trace through this. So again, that unifies with the head of our rule. And then we want to find a hobby for Alice. And the very first hobby line here says Alice likes bird watching, so that's what we unify with. Now we need to find, is there someone else that likes bird watching? Because this was an unbound variable, there's still some wiggle room here to find somebody that can fit this sub-goal. So if we ask who likes bird watching, this will start at the top of this list and look for a hobby, where this first term can be anyone, and this second term must be bird watching. So as we'll see, that unifies with the very first line, hobby Alice, bird watching. Well, wouldn't you know? So walking through, sorry, I double tapped there. The next line says we have Alice likes bird watching, and Alice is another person who likes bird watching. But are those two different people? Does Alice not equal Alice? That's false, so this causes that to backtrack, and we end up trying to resatisfy this line before it. So it says redo hobby someone bird watching. Is there somebody else that likes bird watching? So we tried this first line, so let's continue on with the next line. That doesn't match bird watching. None of these other ones do. We get all the way down to line 10 here. Charlie likes to bird watch. So that's successful if we unify Y, or this person 2, with Charlie. Okay? So then we walk through the next line. Does Charlie not equal Alice? Sure enough, those are different constants. So that's successful. And now we try to find their names and ages. So person Alice for some age. That unifies up here. Alice is 20. Person Charlie. We get Charlie is 23. So then we do a bit of math here. 23 minus 20 is 3. And 3 is not less than 2. So it gets all the way down to this last line with age diff being 3, because Charlie's 23. And that's too big of an age difference for this definition of friendship. So they can't be friends, and that fails. So this didn't work, and now it's going to start backtracking all the way back up this tree, as it is, that it's creating for this search. So there's no other way to do math. Math doesn't really have multiple interpretations, at least when we're just dealing with simple arithmetic. So that's not something we can redo. We can try to look for other persons, so a different age for Charlie, but as we can see, there's only one age for Charlie, so it's not going to find another one of those. Similarly, there's only one age for Alice, so it can't find a different way to unify that subgoal. With equality, again, there's generally only one answer, so it gets all the way back up to this goal again. Is there somebody else that likes bird watching? So it says redo, is there somebody else that likes bird watching? So we jumped all the way back up to this one, and sure enough, there is one last step here. Dave likes bird watching. And I believe we've already seen the rest of this. So if we unify person 2 with Dave, Alice isn't Dave, we get both their ages. They're both 20 years old. Difference between that is 0, so they can be friends. There you go. So then our initial query is true with the unifier that person 2, or Y as our original query called it, equals Dave. And that's the idea behind backtracking. So in this video we see a few things. We saw that resolution is the step-by-step process of resolving goals, or the queries that we're posing. It goes left to right through the different sub-goals that we pose, which is matched top-down through the knowledge base, backtracking, which is ununifying and retrying when necessary.